Good evening. My name is Brian Gromkowski. I'm one of the assistant directors of graduate admissions here at William Patterson University. I'm joined by my colleague Christina Aiello, as well as Dr. David Nacin, who is going to be speaking at length about our MS in Applied Mathematics. He's the program director and is going to share information about his program with you. Just want to go over a couple quick pieces of housekeeping before we get started. First, I want to make sure you're aware that we are going to be recording this presentation in its entirety. I know these have certainly been challenging times for everyone. I know time is even more precious than ever, so we really do thank you for taking time out of your evening, your daily life to join us for our presentation today. We hope to present a lot of very helpful information in a relatively short amount of time so you can get back on with your day. And if for any reason you need to leave us early for one reason or another, we want you to have the opportunity to catch up on anything you might have missed. So we are going to make this available on our YouTube channel. You will be getting an email with a direct link before the end of the week, and that would give you the opportunity if you had to duck out early, or if you have any friends or colleagues or others that you think might benefit from the opportunity of watching this presentation further down the line, that you'd have the opportunity to share it. The other thing I'd want you to know is we are going to make time, if it's necessary, at the end of our presentation for question and answers. You can always type questions there in the chat box on the GoToWebinar screen. If it's something admission-centric and my colleague Christina can answer it quickly for you, she can just type a quick answer. If it's something that would be a benefit for the full audience, we'd read it off at the end, and then Dr. Nacin would have the opportunity to address your question. So certainly I know you're not here to listen to me talk away. You want to hear what Dr. Nacin has to say. So without further ado, Dr. Nacin, take it away.
Today. Oh, hello everyone, and thanks for coming today. I'm Dr. David Nacin. I'm from the Math Department. I am the director of the graduate program for our master's degree in Applied Mathematics. And I'm here to tell you a little bit about our new program. Now, our program will be going into its second year now. It's still fairly new. So why are we doing this? Why did we develop a new program in mathematics? And the main reason that we did this is because it's where the jobs are right now. If you look at the top 100 jobs in America, the top 38 consist solely of jobs in math and healthcare. Some programming, but those programming jobs are very mathematical too. So the jobs are out there right now, and we wanted to create a program to help train students for actual jobs. According to the Bureau of Labor Statistics, this is the most accurate data that you can get in a time when a lot of jobs are going down in growth. The growth rate of statistician jobs is increasing by 31%. It's predicted to increase by 31%. For mathematicians, also 26%. And for operations research, which is what our discrete track will be helping train you for, that's also increasing by 26%. So the jobs are out there, and this program is designed to help take students and train them for actual careers in mathematics. So what would you need to do in order to apply to this program? Well, we're going to need transcripts of all of your undergraduate coursework. You need at least 15 credit hours of mathematics or statistics. We need a personal statement from you to tell us why it is that you're interested in our program. And for people who are not native English speakers, we need scores showing that you are proficient enough in the language for our program, because all of our courses are taught in English. There are some optional things as well. You could take the GRE general test if you wanted to submit that. You could also present letters of recommendation. These two things are not required. So what would you be doing in our program? Well, in the first year, we have all students take classes that are both in discrete and statistics. And as you move on to the later year, your second year, then you would be branching off and specializing in one of the two areas. So for your first year, you'd be taking principles of mathematical analysis, just sort of general analysis that would be used for whatever courses that you'd be taking moving forward. There are applications in both stat and discrete to analytical methods, so that's important. Topics in linear algebra will introduce you to linear algebra, but also it will train you in Python. So there's going to be a certain amount of programming in several of the courses in this program. And the languages that we will be teaching are Python primarily for the discrete courses, and R primarily for the statistics courses right now. Currently, Python and R are the #1 and the #2 languages in data science. So these are the languages that are actually most in demand. And hopefully every student will get out of the program knowing quite a bit of both of these two languages. So 5200 will also train you in your introduction to Python. 5300 probability will help you with your future statistics courses. And then in the second semester, there will be some statistics and some discrete mathematics to get you to know both subjects a little bit better before we make our choice and move forward. Eventually, you're going to be doing some research. There will be a graduate seminar in mathematics to sort of train you how to write presentations, help you with LaTeX, which is a language that people use for typesetting mathematics and statistics. And eventually, you'll be taking your research experience or a thesis option, either a smaller research project or a larger one based on your preference. So what are the two concentrations going to have you guys doing in your second year? Well, for the second year, I have applied algebra, which is an introduction to sort of enumeration and abstract algebra techniques for with applications to counting and all sorts of things. For Math 5610, we have number theory and cryptography. We actually have someone on staff who studies elliptic curve cryptography, a number theorist. So there will be actual, and this is a new method of making encrypting codes through using curves in space. So that's something that you'd learn in a course like 5610. Topics in graph theory, well, these are things that come up in operations research. If you have real world problems, like let's say you have some network of I don't know, telephone lines, and some of them are going down, and you're looking for the most efficient ways to reroute things. Well, you could label things in terms of dots and lines, and mathematicians call these dots vertices and the lines edges, and we put them together, and what we do is we call these graphs. So that's what we'd be studying in a course like that. For algebraic and enumerative combinatorics, we get into more advanced counting techniques, and experimental mathematics is the art of doing mathematics with a computer assistant. So basically, you conduct experiments by machine, and you use those experiments in order to make your conjectures. Now, obviously, by now, you've probably guessed that I'm on the discrete track. For the statistics courses, I don't have as much to say because I don't teach those classes as well, but you can see exactly what we're offering right here. We have a flowchart talking about which courses require which courses. You'll see the courses at the top don't have any prerequisites at all, or anything that doesn't have an arrow in front of it doesn't have any prerequisites. So in the top row, you'd see our first semester courses. In the second row, you'd see our second semester courses. And then everything below that, you can sort of see what's required for what and determining what you might want or not want to take. Here's our department, a fairly recent photo. One person in it is retired, but the rest of us are all still there, and we have someone new as well to replace them. Those are the faculty members. But of particular interest are the faculty that are in these two areas of discrete mathematics and statistics. So we have Dr. Carol Bullitt, who is a number theorist. We have myself. I study non-commutative algebra and combinatorics. Dr. Vega is the one that's done elliptic curve cryptography in the past, also does all sorts of things, financial math, different areas of number theory as well. And Dr. Zalecki doing reorder arrays. For the statistics faculty, we have Dr. Peter Chen and Wui Lim, both of them statisticians studying in different areas. Here's just a shot of our computer lab where some of the classes are held. Several of the classes are held. We have a learning center. This one has a mix of graduates and undergraduates together studying for courses. Some graph theory on the board here and some other discrete mathematics here. But that's really what I wanted to tell you about today. If anyone has any questions or just anything they want to comment on or ask me, feel free.
Okay, as of right now, there are no questions that have come through. So I'll just touch upon a couple things real quick again. And I know sometimes that jump starts a question or two coming in. Want to remind everyone that we did record this presentation in its entirety. This gives the opportunity, if you need to refer back to any of the information that Dr. Nacin went over. If you want to share this with a colleague or friend or otherwise who you think might benefit from the opportunity, we'd certainly appreciate if you did so. And also want to make sure you are aware that that is going to be emailed to you directly. It'll have a link to our YouTube channel, and you can expect that before the end of the week. One question, could you talk a little bit about deadlines for the program? For the terms that you welcome students, what the deadlines are and sort of the review process?
Okay, sure. So, I mean, the review process is based on the transcripts and the letter that we get from the students. So we have a graduate committee that looks at applications, and they make the final decisions. Applications for the upcoming fall semester should be submitted before August 1st. So it's better to have things earlier rather than later. Obviously, it's nice to get things in, but yes, August 1st would be the cutoff.
And then obviously, I know with everything that's gone on with COVID, and certainly I know that's impacted departments differently in how they're adapting to the scenarios we find ourselves in right now. And certainly with the fall and beyond, it's hard to say exactly what the semester might look like. But could you talk a little bit about how the department has handled high flex or hybrid options, any ways that your department has had to adapt in terms of the virtual instruction and other things that have taken place?
This is a beautiful question. Thank you for asking it. Sure. So first of all, something I should add is already we try to be very flexible. All of our courses are either taught at night or on the weekends. So we have nighttime classes, we have weekend classes. We understand a lot of people who enter our program have full-time jobs. Maybe they're teachers, maybe they're in some other industry. Doesn't matter what they're doing. We do attract several teachers as well, though. That's the only reason I give that as an example. So our classes are all either in the evenings or on weekends to begin with. Now, since COVID came out, our original plans were for these to be more in-person evening and weekend courses, but because of the epidemic, what we did is we made everything online. So everything was online last semester, everything is currently online this semester. What I can't say is I can't say exactly what the state of the university will be in the fall exactly. However, we do plan to keep the nighttime and weekend schedule, and we plan to offer online options as well as because they are convenient for the students. So I don't know for sure exactly what we'll have, what might have an in-person option and what might not. Sometimes it's helpful to have everyone together typing together in the computer lab if there's some sort of a project. But like I said, we do really try to make our schedule convenient for people who have sort of different work schedules, and we do plan to continue to do that.
And then one question that gets asked often, and I apologize if you would address it earlier in the slide, but could you talk a little bit and how long it would typically take a student to complete the program? Would most be coming in full-time, or if a student was pursuing part-time study?
So a student could pursue part-time study if they wished. However, the program is designed to be completed entirely in 2 years. So there's 9 credits in the first semester, 9 credits in the second semester. So that already brings us up to 18 credits, and there's 12 credits over the next 2 semesters. Though in the last semester, part of that is going to be your research project, your research experience, or your thesis project, which can be quite demanding. So you wouldn't be taking as many classes during that. And that's why there's also fewer credits in the second year.
Okay, thank you very much. It looks like there are no additional questions that have come in as of right now. So Dr. Nacin, unless there's anything else you want to add, I can send everyone off to enjoy the rest of their evening. All right. Thank you, everyone. For all of us here at William Patterson University, again, I can't thank you so much for your time. I know these have been very difficult times. Whether you've taken a break from work, from family, from dinner, or any other number of things that could distract and take away attention right now, we really do appreciate your time. We hope this webinar was helpful. Again, you can be on the lookout for an email with a direct link to the recording before the end of the week. Thank you all so much. And if you haven't already began an application, we hope you'll consider doing so for the program in the very near future. So thank you very much and have a good evening.